Today we're going to be talking about translations. This is a video specifically for regular geometry and does not cover everything that you're going to need in Geometry Q. So go back and look for the Geometry Q video if you're in the honors class. Okay, so first of all, let's talk about what is a translation. So if we took this line segment and we wanted to move it from here and we wanted to move it down and to the right, that would be a translation. We would create our new figure, in this case a line segment, A prime, B prime. And a couple of things that are really important with a translation. First of all, your first image or figure is going to be called the pre-image, just like when we were doing our reflections yesterday. Second of all, the pre-image and the image that's created after the transformation, they're both going to be congruent figures. They have to be exactly identical. There's no change in size at all. And a translation, you might have heard this referred to before as a slide. So it looks like we just took line segment AB and we are going to slide it around the page wherever we want. One new term that we're coming up with here, these light teal arrows, these are called vectors. They're actually translation vectors. This is a translation vector. And it tells you what direction and exactly how far to move your figure. Now that figure can be anything from a point all the way up to a polygon of any sort. And so when we're talking about these, just keep in mind, if we're asked about a translation vector, then it's just talking about the direction and the distance that we are moving our figure. And it's really important to know, like if A moves along this translation vector and it's 2 inches long, then B is going to move along a 2-inch translation vector. It goes exactly the same direction. And that's really important. Okay? So we're going to talk about more specifically or more usefully for us is a translation on a coordinate plane. So if you have a triangle, like this triangle, LMN, and we want to translate it, there's 2 ways that they might give us instructions to translate this triangle. First, they might give us instructions like this one where it says go down 4 and right 2. So we're going to take each coordinate and we are going to move down 4. I'm going to start at M and count down 1, 2, 3, 4, and to the right 2. And I put my new coordinate. And so the original was M, so this is going to be M prime. I do the same thing with each of my other coordinates. So N, and I would move it down 1, 2, 3, 4, and over to the right 1, 2. And this would be my new coordinate for N. And point L, okay, move down 1, 2, 3, 4, and to the right 1, 2. And this would be my new coordinate for L, for L prime. And so then we would go ahead and we would connect each of our coordinates. Right? And you're going to notice this was a right triangle up here. This is a right triangle that we've created. All we did was take that figure and slide it over. If your instructions are given like this, it's usually easier if you go ahead and graph it first and then make a list of your new coordinates over here on the side. Right? L prime, M prime, and N prime. Okay? So that's usually the easiest way to do those. However, sometimes you're going to be given instructions that look like this. So this is triangle TUV, and our instructions on this one are written like a coordinate, only they've been added to or subtracted from. In cases like this, it's usually easier if you go ahead and write out your original coordinates first, and then go back and plug them into this here, which is going to be like your formula. Okay? Every time this will change. Sometimes you will have something added to both x and y. Sometimes you'll have something subtracted from both x and y. Sometimes one might be added to, but the other one might not be, okay, or subtracted from, and the other one isn't. So just keep in mind that that formula is going to change depending on what translation they want you to perform. So let's go ahead and list out our original coordinates. So t is at -5, -1. Oh, oops, sorry, I can't read my own writing here. -1, -4. U is at 6, 2. And V is at 5, -5. Now we are going to translate each of these, okay? And as we do that, we are going to have a new set of coordinates, right? So for t, we're going to have -1, and we're plugging that in because it's the x coordinates, so we're plugging it over here. So it'd be -1 minus 4. So we're going to have -5, and then for the y coordinate, we have -4 plus 3. It's going to be -1. For u prime, 6 is our x coordinates. We have 6 minus 4, which is 2. And for the y coordinate, we'd have 2 plus 3, which is 5. And v, we would have, our x coordinate is 5, so 5 minus 4 is 1. And our x coordinate, or sorry, excuse me, our y coordinate is -5 plus 3 is going to be -2. Alright? So, and that was v prime. Now we want to go ahead and graph those and make sure that our new triangle looks like our old triangle. So let's go ahead and start with t. So you can count back to -5, and then down 1. So that is coordinate t prime. And that moves from here. Then we'll do u. We started here, and we're going over 2 and up 5. So over 2, 5. So this is u prime. And then v, which was originally down here, and it's going to go over 1 and down 2. This is v prime. We can go ahead and connect all of our coordinates here. And that is our new triangle. And what we're looking for here is that our triangle looks like it's about the same size and should look, the same shape. So if you had an isosceles triangle before and now it's a scalene triangle, that would be a sign that something's wrong. Or, it was an acute triangle before and now all of a sudden it's an obtuse triangle, that would be a sign that there's something wrong. So these aren't super duper challenging or anything like that. Just remember to write down your coordinates first and then follow the formula that you're given. Thank you very much. I hope you have a great day.